Hello, everyone. This is Francesca Vigliani from Cloud Academy. Thank you for joining us for episode number 2 of our Pandas Like a Boss webinar series. We're so happy to see such an international audience connected with us today. Thank you for taking some time away from your day to join us. So before introducing our speaker, a few housekeeping announcements as usual. I'd like to remind you that this webinar is being recorded and will be shared with you via email. During the webinar, we will leave time for your questions, so feel free to add them in the chat box and our expert will try to answer them during the final Q&A. Lastly, we hope you had time to set up the environment so that we can get going with the session. And if you had problems, don't worry, you just need to have the data on your Google Drive. Andrea will show you how to read the data from that source. Okay, I'm all done with the announcements, so without further ado, let me introduce you to our data scientist, Andrejo Sani.
Thank you, Francesca, and welcome everybody. It's nice to see so many people here today, so thank you for participating. Okay, just a brief introduction of myself. I'm a data scientist here at Cloud Academy, where I mainly focus on the development of machine learning algorithms to provide state-of-the-art solutions to improve the quality of our product. You can reach me out on LinkedIn, or you can visit my website for updates on machine learning or Python in general. All the details can be found in the webinar-specific GitHub repository, and the URL is provided in the registration email. So check that out. And there I will also upload the full transcript of the webinar as soon as we finish the session. Okay, so the agenda goes as follows. We are going to recap a little bit what we did last time, and then we are going to jump into today's topic. So, well, this is the second episode of our Pandas series. I hope you have enjoyed the first episode where we have understood how to filter a data frame. And we have seen different methods to do that, moving from the classical location attribute to the modern query method. If you have missed that, don't worry. The webinar is publicly available on the Cloud Academy YouTube channel. Today's webinar is very interesting. It's entitled How to Manipulate and Manage a Data Frame. And I believe any data scientist and engineer must know in order to successfully perform their daily task. In particular, today we are going to understand how to manage and manipulate a data frame, and we are going to see basically 3 main functions. The first one is the Concat method. The Concat method allows us to concatenate 2 or more data frames into one. We're going to explore also the merge method, which basically merges 2 data frames in one. And finally, we are going to check the explode method, which is useful when you have to propagate a value list among rows. Again, even today, we are going to use the Google Colab environment to perform all the necessary steps for this webinar. I have written a README on how to set up a Google Colab notebook if you're not familiar with it. I assume, however, that you have read and set up the environment already, since all instructions were provided before the start. As for the data, we are going to take into account 2 data frames that contain the time series of the Amazon and Tesla stock, respectively. In particular, we are going to take into account the series of the closing price and the corresponding daily volume. So that's it for the moment. And without further delay, let's jump into the Colab environment. You should have something that resembles the one that you see here. We have seen last time how to set up it. And again, don't worry if you are not very familiar with this environment. You just need to basically link your drive to the Colab environment so that we will be able to get the data from that drive. And to do that, basically, we're going to use the Google Colab API. And the instruction is very simple. We are going to import from Google. From Google Colab, we are going to import a drive. And then we are going to mount our drive by passing basically the path to the drive, which is content/drive. So I have been already mounted my my drive in the Colab session. Possibly you haven't, so you will be asked to authorize basically the Google Colab to read inside your drive. So just insert your credentials, and therefore you will authorize the Colab to read and mount the drive. Once you have done that, you can check that everything has been mounted correctly. On the left panel that you see here, you can see that you have a My Drive folder where you should see some, your personal stuff. Okay, so let us import Pandas with the standard convention PD. And today's topic requires merging different data sources. So let us import the two data frames that we are going to use today. As I said before, one is related to the Amazon series, stock series, and the other one is related to Tesla. I have stored those data sets into a folder called SIA Webinars, and I have here in this data folder. So what I'm going to do is basically to copy the path that I see here of, let's say, Amazon CSV, and I'm going to read the file using the Pandas Read Csv method. And I'm going to store this object into the variable Amazon_df. And I do the same also for Tesla, since we need both data sources. I store this into, let me say, Tesla _df, and we are going to pick the file that is placed in the content drive, and basically this is your path, and then I'm going to pick the Tesla as well. So let me run this cell, and just for curiosity, let us inspect the first 5 rows of the Amazon_df data frame. So can you spot a potential issue here? It's not a big issue, but if you pay attention, we have an unwanted column basically here, namely unnamed. This might happen, especially if you store a data frame using Pandas with the method 2 CSV, and you forget to specify that the index must be false. So basically, this is nothing more than the index of the original data source that we store into a CSV. And if you pay attention, it's obvious that is an index, because we have actually a mapping between the index, the actual index of our data frame, with these numbers. And nothing more is the range of integers starting from 0. So we might think of using this column as the index of our data frame, so that we completely remove it from the data frame. And to do so, we can set directly inside the read CSV function, we can set up the argument that is the index call, and we set this as equal to 0, meaning that we are going to pick the column in position 0 from our data frame, that is the unnamed, and we set as index. We do the same also for Tesla. And we run again the cell, so that if we now inspect the first 5 rows of this new data frame, not surprisingly, the unnamed column has disappeared, since we have set that as the index of our data frame. Okay, so let me just also describe a little bit the data. So both the Amazon and the Tesla data frame are characterized by 4 columns. We have the date, which basically describes the trading day that we observe, that basically we observe those values. And those values are the closing price and the volume. You also see that we have a column called symbol, which basically describe the stock we are taking into account, namely Amazon for the Amazon data frame and Tesla for the Tesla_df data frame. So not surprised here. Why? Because actually we are basically isolating stocks thanks to the data frames. So in Amazon DF, you will find just values related to Amazon, and in the one of Tesla, all values related to Tesla. So there is no surprise that in the symbol column, you will find just the Amazon and Tesla respectively. So as a first check, we might think of, let me say like this. As a first check, let us see whether the two data frames have the same shape. This is important since basically we want the two data frames to be consistent with respect to each other. And to do so, we might employ, for instance, a Boolean condition and check that the number of rows and columns in the Amazon data frame is the same as the number of rows and columns in the Tesla one. And to do so, we basically use the shape attribute on the Amazon, and we check with a Boolean condition that the same is inside the Tesla data frame. If that is true, then we are sure that the two data sets are consistent with each other. It's true. So basically, this means that both have the same number of rows and columns, and you can get those numbers by using the shape attribute, and you get that we have 147 rows and 4 columns, respectively. So since they are consistent with respect to each other, we might think of merging them. And today's webinars basically is going to show you how to deal with different data sources, and we are going to explore methods that allows you to concatenate and merge those data sets into a data frame. So as first, let us explore the concat method. The concat method is used to concatenate 2 or more data frames. And let me say that the syntax is extremely simple. You just need to call the concat method, and you need to pass a list of data frames you wish to merge. For instance, in this case, we have 2 data frames, namely Amazon _df and Tesla _df. And therefore, we want to merge all together so that you will get just one final data frame that is made of the concatenation of the rows that makes Amazon and Tesla data frame. You have a very important argument, which is the axis equal to 0 by default, meaning that so basically the argument axis controls the way in which we are concatenating. Axis equal to 0 means that we decide to concatenate data frames by rows, meaning that all the rows of Tesla will be appended after the ones of Amazon. But you can also control these, and we will see in a moment that you can control also by columns. So for the moment, let's concatenate by columns, by rows, sorry, with axis equal to 0. And we store these into, let me say, a variable called concat data frame. And we can inspect the shape. Since we are concatenating 2 data frames, we expect that the shape is going to be the sum of the two, and that is confirmed since we have 294 rows, which is the sum of both data frames. And we have the same number of columns, since we know that the columns are consistent. And let me also check, as a final remark, the tail of that data frame. In order to do that, I apply the tail method on the concat df. And can you spot a potential problem here? If you pay attention, the index has not been updated. What I mean is that we have 294 rows, but the last row of our data frame has still 146 as index, which is misleading, right? And that is simple, since we are just appending the Tesla data frame below the Amazon one. And we are not basically resetting any index from the original one. Life is easy, especially if you use Pandas, and therefore we can think of resetting the index so that we are not gonna have anything related to the old data set. And to do that, we employ the reset index method. And the reset index method basically requires you to specify the argument drop, which I set equal to true, meaning that I'm gonna drop the original index that you see here, because it's not gonna bring us any useful information at all. So let us drop it, just forget about that. And we can also do an in place operation, so that we don't have to reassign that object to a new variable. If you now run again the tail method on that data frame, you see that now the index has been reindexed, and that is much more consistent with our analysis, since we have 294 rows, and therefore reading the data set in this way is much more direct and readable. Okay, so let me also show you the first 5 rows. And what we can think of now is to try to sort the values that we see here inside this concat_df object by date. Why? Because in this way we're gonna have a sorted data frame by date, and that possibly is much more readable for the final user. So in order to do that, we employ another function from Pandas, which is the sort values, which require you to specify the argument by, which is nothing more than the column you wish to use to sort the data frame. And that is nothing more than the date. And we can try to print out the first 5 rows. And if you see now, we are sorting by date with this nice function. And this is consistencies. Now we have the first row related to Amazon, and the second one is related to Tesla, but the date is the same as the one that you see here. So the method sort values, once applied, works well, but still we have a problem. We have the problem of, again, the index. So we just need to reset the index again. We remove the index, but still we can improve the readability of that data frame. And for instance, we can think of sorting not just by date, but also by symbol. And that is quite clear, especially from this output, because if you think about, we are sorting by date, and we have in the first occurrence, that is July 1st, you have first an Amazon observation and then a Tesla one. But then look for the July 2nd. You have first observation Tesla and then Amazon. So you don't have any consistency on the way we have sorted the data frame, because Amazon might appear before Tesla and vice versa. There is no logic. We can apply a logic, obviously, and the logic is simply by sorting, not just by date, but also by symbols. And to do that, we basically apply the sort values by passing not just a string, namely date, but a list of strings, where those strings are nothing more than the columns we wish to sort. And in this case, it's going to be date and symbol. Let's try to run this cell. And here we go. Now it's much more consistent, right? Because you have, for the same date, you have that your observation have been sorted alphabetically with respect to the symbol. I guess this is basically a good output, so we can actually store this data frame into the variable final_df. And again, just for simplicity, I just call it with the head method so that we have the first 5 rows printed in our collab session. I want to give you also an extra tip. Let me say like this. So you could have obtained the same result using a different function from the concat one, and that function is the append. Basically, you can take the Amazon_df function, data frame, sorry, and you apply the append function, which requires you to append another data frame, in this case Tesla. Unfortunately, this is not happen in place, so we have to assign this to a new object. Let me say new_df. And let me also show the first 5 rows just to give you an idea of what's going on. We are appending as before with the concat the 2 data frames. So we have the Amazon, and then we append after the Amazon data frame all the rows related to Tesla. And since we have understood that we need to reset the index and sort values, we just need basically to apply the same logic that we did before on the new_df. And we basically apply the sort values and we sort by date and symbol on that particular data frame. We reset the index, and I store this into a variable called final_df. Let me call it 01 just to distinguish it. And without any surprise, if you inspect the first 5 rows, you get exactly the same result as we did with the concat. Just note that we have used 2 different methods. We have used the concatenation method at the beginning. Here instead we have used append. It's just an extra tip that I want to give you, but you know, the 2 methods are exactly the same. You get the same result at the end. If you have any question, just leave your curiosity on the chat, and then at the end, as Francesca said at the beginning, I will answer to your question. Okay, so let's jump into the second method that I want to show you today. And basically, the second part is related to the merge method. And therefore, I'm gonna entitle this section as merging 2 data frames, since we are going to basically take into account those 2 data frames and try to merge them together. Okay, let me go back to the concat function. If you remember, I said, well, the concat function requires a list of data frame, and then it has an argument, which is the axis, which by default is equal to 0, meaning that we are appending by rows. But if you set this equal to 1, basically you are gonna concatenate the data frames by columns, meaning that you are going to append the Tesla data frame, all the columns of Tesla, after the columns of Amazon. Just to give you an idea, what I'm speaking about is the following use case. With axis equal to 1, I'm just adding columns to the Amazon data frame, and those columns are related to the Tesla data frame. Can you spot a potential problem again here? Here there are many problems, right? First of all, look at the column date. The column date is repeated twice, and therefore is not bringing any useful information at all, because you just need to know that once that in that particular day there was a trading session. So this information is redundant. You don't want that. And also, the data set is not tidy. A tidy data set, when I speak about a tidy data set, with tidy I mean that a single row basically identify a unique observation. And therefore the data set is not tidy, because in one row, namely the first one, I have observation related to both Amazon and Tesla. And a tidy data set requires instead that each single row describe a unique observation. If you are curious about tidy data sets, you can check our course Data Wrangling with Pandas to learn more on tidy data sets and why they are important. For the moment, just keep in mind that a tidy data set is a data set where each single row describes a unique observation. Okay, so since it is not tidy, let's go and try to make the data set tidy. How can we do that? So what I want to do with you is to try to define a custom method that we are going to call it tidying dataset, tidying underscore df, that basically ingests a pandas data frame. Okay. And this custom method is going to perform basically 4 operations. So the first operation is nothing more than we are going to extract the symbol of the stock we are interested in from the original data frame, that is the df that you see here as argument of our function. So I'm going to define a variable called symbol, and this symbol is nothing more than the original data frame in position symbol, and I want to extract just a single value from that particular column, and therefore I can employ the drop duplicates that is going basically to drop all the repetition that we have. Think about having this symbol column. We are going to drop all the replication of the Amazon string so that we are going to just get one string, and we access to that particular value with the attribute values in position 0. Once you have done that, as a second step of our custom method, we are going to basically remove unnecessary columns from our business logic. For instance, we want to remove the symbol column and the volume, since we want to compare just the closing price from Amazon and Tesla. So to do that, we basically apply the drop method on the data frame, and the drop requires a list of columns we wish to drop, namely symbol and volume, we said. And we perform this operation by columns, namely we are gonna drop all the columns by specifying axis equal to 1, and we do this operation by setting in place equal to true. Third step, we are going to set the index of our data frame by setting it with the date column. And to do that, we employ the set index function from Pandas, and we specify just the name of the column we wish to have as index of our data frame. And again, we can do this operation in place by specifying in place equal to true. Finally, since we are going to have just one column in our new data frame, we can think of setting the columns of that data frame, namely the columns attribute, by setting it as equal to the symbol we have extracted in the first row of this method. Finally, we return the result in this way. Just take your time to digest it. I know it's a lot of stuff, but there are 4 simple steps that can be wrapped inside a custom method. Why did I do that? I choose to wrap everything in a method because we are going to apply now the tidingDF method to both the Amazon and Tesla data frame. And therefore, we are not going to repeat any redundant code in our session. So for instance, as I said, let's apply this to Amazon DF. And I'm going to set this new data frame into the variable Amazon _df _egg, standing for aggregate, and apply this method to the Amazon _df. And the same for Tesla, right? So Tesla _df _egg is nothing more than the application of this tidingDF method on the Tesla data frame. Just for your curiosity, let's try to look at the first 5 rows of this new data frame, Amazon _df _egg. You just see a one column that basically the name of that column is nothing more than the symbol we have extracted. We have an index that is nothing more than the date, as we have done here. And the value of that column is the closing price. Because if you think about, we have dropped all the columns except the closing. The same is done for Tesla, obviously. So no surprise here. And therefore, since the 2 data frames are consistent with each other, we can think of merging the 2 data frames into one. And to do that, we use the merge method. The merge method is applied on a data frame and requires at least 3 arguments. The first argument is basically the data frame we wish to merge with. In our case, is Tesla _df _egg. And then we have other 2 important arguments. Basically, one is the on argument, which is basically the key on which we want to merge the data frames. So obviously, if we are merging 2 data frames, those keys must be present in both the data frames, otherwise the merge is not possible. And if you think about one possible key for our simple scenario is the date. So we can merge basically on the date. And an extra argument, very important, is the argument how. The argument how basically is the kind of merge we want to perform. If not specified, inner join will be implemented. And if you are familiar with the SQL language, basically this is nothing more than an inner join, SQL inner join. But basically you can specify it with the type of join you like, a left join, a right join, an outer, whatever. The most important thing is that the join requires the argument, the key argument that is present in both data frames. So as I said, I'm going to use the default, the inner join, and that's it. So with just one line of code, we are able to merge two data frames on a common key, in our case date. And if I show you the first 5 rows of the result data frame, it's going to be nothing more than the concatenation of those two columns, Amazon and Tesla. But the concatenation is not a proper concatenation, it's a merge of the two data frames with respect to a common key, namely the index data, so that any other information is repeated. So the column date is not repeated twice. We are merging on that column so that it's not repeated in the output. And we can basically store this into the merge underscore df. And let me say also like this. You could use also the concatenation, the concat. So for instance, let me do like this. If I write pd.concat and I pass the Amazon underscore egg and the Tesla underscore egg, and we do this by columns, you basically get the same result, right? You are basically concatenating the two data frame with respect to the same index. So here the merge was a little bit more extreme, was an extreme operation, because we could have obtained the same result with a simpler operation, which is the concat. However, the merge operation, the merge function, is useful when you want to merge on not just with respect to the index, but with respect to some columns that are shared by both data frames. In that situation, the merge is much, much better than the simple concat. And the motivation is simple. If you have two columns that are present in both data frames, then those columns, if you employ the concat, will be repeated twice in our case in the resulting output. And you don't want to replicate the columns since they are bringing just rumors, you know. And so in order to avoid that particular scenario, you use the merge. But in our case, since we are merging with respect to the index and life is easy in our example, you can obtain the same result using this syntax, which is much more simpler. Okay, to recap a little bit. So if the objective is to append data frames by rows, you should go with the Pandas Concat method. If instead you want to append by columns, the solution in general is the Pandas Merger, which merges on the columns of the data frames in common. The specification we have seen here, concat with axis equal to 1, is recommended only when the data sources are intrinsically homogeneous. What I mean is that basically when we don't have any information repeated in both the data frames. In our case, this case is quite a good example, since you have homogeneous columns in both data frames that describe a unique company, namely Amazon and Tesla, and the index is common, and therefore you merge on the index. Okay, we are getting to the last part of the webinar, and I'm going to show you a very nice method, which is the explode. And the explode method basically is not extremely used daily, but it is very nice, and it allows you to perform propagation of list values inside a data frame by row. To illustrate this, I'm not going to use the data sets that we have employed so far, but I'm going to build a toy example with you on the fly. And in particular, I employ the data frame function from Pandas. Sorry, is the pd.dataframe. And in particular, we create a data frame in this way. We pass a Python dictionary, and this dictionary is made of, let me say, two values, two keys, sorry. The first key is nothing more than called user, and its values is nothing more than a list of names of, let me say Cloud Academy, okay? So those users are Andy, Richard, and they are Jeremy, okay? So we are 3 users. And another key of this dictionary is ratings. So those are students that, you know, take some courses in Cloud Academy, and then they rate the courses. And this is nothing more than a list of lists. So we are going to have 3 lists here. So Andy gave 5 for 5 for 3 courses. Richard gave, let me say, 4, 5, 4, and then Jeremy gave 4, 3, 5. Okay, just a random numbers. It doesn't matter. It's just a toy example. We store this into the variable df, and if you print this data frame, it's very simple, 3 rows. But the interesting fact is that the ratings has for each single row has value described by our list of values. So what we would like to do is to have a tidy data set where each single row describe a pair of user rating. And to do that, we employ the explode method that propagates the values inside the list associated to each single user. The syntax is very, very simple. We just need to apply the explode method on the data frame, in this case df, and we specify the columns, the column we wish to propagate. In our case, rating. With Pandas, life is easy. So if you try to run that, you get a exploded data frame. It's melted right now because we have exploded it, and you have that the user Andy has 3 observations, and Richard as well, and Jeremy as well. And namely, those values are nothing more than each single one that you find in this list. So the function performs well. The only things that we can do is just to reset this index, namely with the reset index, and we drop it. And basically, we get a melted data frame, which is tidy since each single observation, each single row describes a statistical observation. And we are happy with that particular output. So this concludes the webinar. I'm now open to answer to all your questions. So I see there is one question just come now. So it's okay. It's a very good question. The question is, how can I explode multiple columns? This is a good question. So let me say like this. Suppose that you have instead of ratings, let me say like this, you have a column that, a key that is called system, which is nothing more than the operating system you use to watch the videos on Cloud Academy. Let me say like this, the Android, iOS, and just random stuff, okay? Let me add this. And then iOS. Okay, so we have just added a few examples here. So this is an interesting question, since actually we could explode the data frame using the following syntax. So we can apply, we can do the following. So let me firstly print the following data frame. So what we can do now is to set the user column as index of our data frame. And then we are going to apply basically the explode method for each single column, so that we are going to have a pair of user rating and the user system at the end. And to do so, we can set the index, namely we set the user, and then we apply the function explode on each single column, namely we apply the Pandas series, and we apply the explode on that particular series. And finally, we reset the index, since we don't want to have strange numbers as index. If this is true, then we should get a data frame that has been exploded and has as granularity the triple user, rating, and system. And in this case, indeed, we have that Andy gave a rating of 5 with that system, Android, and then gave a rating of 4 with the iOS. And this is consistent, actually, is consistent with what we see in this data frame. Okay, so there is another question which is more general. I guess you missed that at the beginning. All the webinars are recorded and will be uploaded on our webinar page on Cloud Academy website, and you can easily access to them via our YouTube channel. Okay, thank you for the attention.
Awesome. Thank you so much, Andrea. That's it for today. So on top of thanking our speaker, I would like to thank everybody that joined us for this session. We hope you enjoyed it. Before we part ways, just a couple of reminders. You will receive the recording of this session as soon as it is available. Please fill out the end of webinar survey. Your feedback is extremely helpful in understanding what kind of webinars you'd like to see more of and what you thought about this session. If you, as Andrea just mentioned, if you missed episode number 1, you can find it in the webinar section of the Cloud Academy website or on our YouTube channel. And the same goes for all the following sessions that we will hold for this series. And don't forget to sign up for episode number 3, which will take place on March 18th. Again, you can find it on our webinar page on the Cloud Academy website, so don't miss out. Again, thank you for joining us, and until next time, goodbye.